Okay, we're going to be talking about a special system of equations today, what happens with some special ones, special types. We have here consistent and independent. These systems of equations will only have one solution. The lines will cross in one place, and that will be your solution. It's called consistent and independent. The graphs of these lines are only going to cross in one point, and the slopes of these graphs will be different. That's how you're going to recognize them. So if you put them in slope-intercept form, if you'll look at their slope, these two have a different slope. This has a slope of 2, this has a slope of 1. It doesn't matter if their y-intercepts are the same or different. That doesn't matter, but their slopes have to be different. So when you graph these, you will start at 5, you will go up 2 to the right 1, and then if you can't go up 2 to the right 1, you'll go down 2 to the left 1. And this is the graph in blue. This graph is in red, and you will start at 3 and go up 1 to the right 1 like that. These two graphs are going to cross at the point -2, 1. All right, consistent and dependent graphs. This system will have infinitely many solutions. The graphs of these lines will be the same line. Both the slope and the y-intercepts will be the same. So if we look at this equation here, it is y equals x plus 2. If we take the first equation and we put it in y equals format, we're going to have to divide through by 2 to make this y equals. When we divide through by 2, you'll see that you get the exact same graph. These are going to have infinitely many solutions. Every solution that is on this graph is also on this one because they are indeed the same line. So this has infinitely many solutions. Their slope and their y-intercept will be the same. Inconsistent, this has no solution. The graphs of the lines will be parallel. In order for them to be parallel, their slopes will be the same, but their y-intercepts have to be different. So if you look down here, we have y equals 3x minus 1 and y equals 3x plus 2. They're not going to have a solution. If we graph those lines, they are going to make parallel lines, and they are not going to cross. Now, I have these up here because they have been, we're looking at them algebraically or just putting them in y equals format. If you'll notice, I skipped this, well, I did this example, we'll do it right here. Example number 4, 3x plus y equals -1. When you put it in slope-intercept form, you get y equals -3x minus 1. And then when you take -9x minus 3y, you put it in slope-intercept form, and I'm just going to quickly go through this. You move the 9x to the right, then you divide by the -3, and you get -3x minus 1. They are the same line, and they have infinitely many solutions, consistent and dependent. So you won't recognize this, let me just say this, until you put them in slope-intercept form. Now I'm not going to take each and every one of these and go through how you put them in slope-intercept form because you should know that by now. So, but what I want you to see is you can't tell necessarily from the start, so you have to put them in slope-intercept form to see. So when I put this one in slope-intercept form, we get y equals x over 2 minus 2.5. When we put this one in slope-intercept form, you get y equals x over 2 plus 1/2. These have the same slope, but different y-intercepts. They're parallel lines. They have no solution, and they are inconsistent. You come down and you do this one, and you put these two in slope-intercept form, and be very, very careful because these two can be deceiving. This one says y equals -2x plus 4. This one says y equals 2x plus 0. This is positive, this is negative. You have to be careful. You have to be very, very careful. So these are going to have one solution. So, thank you.